Section 1.8, to locate points on a coordinate plane and to describe relationships using the coordinate plane. This diagram illustrates all terms associated with the coordinate plane. Here, we have an x-axis and a y-axis. They intersect at a point called the origin. To the left of the origin, we have negative values. To the right, we have positive. Above the origin, we have positive y values, and below the origin, we have negative y values. The coordinate plane is broken into 4 different quadrants. In the upper right-hand corner, we have quadrant 1. Going counterclockwise, we go to quadrant 2, quadrant 3, and finally quadrant 4. We plot points on the coordinate plane using x and y coordinates. Here, we have point A. It is associated with the x-coordinate of 20 and the y-coordinate of 15. Notice on the x origin, going to the right, 20 units gives us our x-coordinate value of 20. Vertically, we go up an associated y amount of units, which would be 15 units, for my y-coordinate. X-y coordinates have special values inside of each quadrant. For example, in quadrant 1, our x value will be positive and our y coordinate will be positive. In quadrant 2, our x coordinate will be negative and our y coordinate will be positive. In quadrant 3, our x coordinate will be negative and our y coordinate will also be negative. In quadrant 4, our x coordinate will be positive and our y coordinate will be negative. The origin has an associated x and y coordinate of 0, 0. How do we plot points on a coordinate plane? Here I have point A, and its x and y value for the ordered pair, the x coordinate is 20, and the y coordinate is 15. But what if I would like to plot a different ordered pair? Let's say, for example, 3, 6. Then what I would do is start my point at the origin 0, 0. Then I would move to the right 3 units. Then I would go up until I hit my y coordinate of 6. Then I would plot my point A at 3, 6. Another example would be if I wanted a point that was a negative 4, 7. Again, I would start at the origin, go to the left, a negative 4 units. Then I would move into the second quadrant and go up to my associated y value of negative 4, 7 and plot my point A. What if I wanted to plot a point that was on the x or y axis? To plot a point on the y-axis, I would have an ordered pair that has an x-coordinate of 0. For example, if I wanted to plot 0, negative 8. 0, I would not move to the left or right on the x-axis, but I would move down negative 8 units on my y-axis and plot that point on my y-axis. If I wanted to plot this point on an x-axis, the ordered pair would have a y-coordinate of 0. So if I would like to plot a negative 12, 0, I would move a negative 12 units to the left, and then I would not move up or down to the y-axis because my y-coordinate would be 0. And my point would be plotted on the x-axis. Once we have points plotted in a coordinate plane, the next thing we want to do is find the distance between those points. The distance, d, between 2 points, point A, x sub 1 and y sub 1, and point B, x sub 2 and y sub 2, is defined as d, the distance, equaling the square root of the quantity of x sub 2 minus x sub 1 squared, plus the quantity of y2 minus y1 squared. Our first example wants us to determine the length of segment AB. They gave us point A and B and the segment AB. The first step is to determine the ordered pair for point A and point B. For point A, starting at the origin and moving horizontally left to point A, we get a x-coordinate of a negative 4, and vertically to 2 for the y-coordinate. Therefore, point A's ordered pair is a negative 4, 2. In similar fashion, we're going to generate point B. Here, Starting at the origin, moving right horizontally, we get 5 for the x coordinate, and vertically, we're going to get 7 for the y coordinate. The next step is to label these as subunit 1 or subunit 2. It doesn't matter which one you label the ordered pairs, as long as when you start, it finishes in that fashion. So I'm going to call this point 1 and this one point 2. And from that point on through the problem, it will stay x sub 1 and y sub 1, and this will stay x sub 2 and y sub 2. Now, I just substitute those values into my distance formula. Here, the square root of x sub 2, which is 5, minus x sub 1, which is a negative 4, squared, plus y sub 2 is 7, minus y sub 1 is 2, squared. Then we simplify. 5 minus a negative 4 is 9 squared is 81, plus 7 minus 2 is 5 squared is 25. Therefore, the length of segment AB is the square root of 106 units. Next, we want to determine the coordinates of the midpoint M of segment AB, with endpoints of A being x sub 1, y sub 1, and B being x sub 2, y sub 2. The formula for the coordinates of the ordered pair are going to be x1 plus x2 over 2 for the x coordinate, and y1 plus y2 over 2 for the y coordinate. I've broken them into two separate formulas, the x coordinate midpoint and the y coordinate midpoint. Let's look at this example. They want us to find the coordinate of the midpoint of segment FG given the point F and the point G. All we need to do is to label the points and substitute into the given formulas. Let's let this be x sub 1, y sub 1, x sub 2, and y sub 2. Now we just substitute. x1, negative 6, plus x2, which is 5, divided by 2. That gives us an x midpoint coordinate of a negative 1/2. For y sub 1 is 4, plus y sub 2, negative 3, divided by 2. And the y midpoint coordinate is going to give us 1/2. Therefore, the midpoint ordered pair is negative 1/2 and positive 1/2. If we plot that point, a negative 1/2 and a positive 1/2, that will give us the midpoint of segment FG, and therefore I know that FM is congruent to MG. Here they want us to determine the length of RT, and I know that because there is no symbol above RT, to the nearest tenth, and also find the coordinates of the midpoint of segment RT. Here I've labeled my ordered pairs, and I've substituted into my distance formula. When I simplify, I get the square root of 29, but they want us to determine the length to the nearest tenth. When I substitute into a calculator, I get 5.4 units. For the coordinates for the midpoint, I substitute in and simplify, and I get the midpoint ordered pair to be 7 and a negative 9/2. Our next example, the coordinates of P are given. The midpoint of segment QP has coordinates of a negative 3, 7. Therefore, the midpoint ordered pair is a negative 3, 7, and this represents negative 3, and our YM represents 7. They want us to find the coordinates of point Q. Here is the segment that we have. We know point P because it's given to us, 512, and we know the midpoint to be a negative 3, 7. What they want us to find is the location of point Q. It has to be out here somewhere that makes these two segments congruent. Our job is to determine the value of point Q. To do that, we're just going to use our midpoint formulas and substitute in our known values. All I have to do is let point P be x sub 2 and y sub 2. I let point Q be x sub 1, y sub 1, and then we substitute into our midpoint formula accordingly. So here I have xm, I already know that is a negative 3. x1 is unknown, so I let it be x. x2 is known to be 5, all over 2. Then I just generate a proportion and cross multiply. That gives me a negative 6 equals x plus 5. And then solving for x, I get x equal to a negative 11. In the same fashion for y, I know ym is 7. y1 is unknown, so I just let it stay y. Plus y2 is 12, all over 2. Create a proportion, cross multiply, and simplify. I get 14 equals y plus 12. Therefore, y is equal to 2. So the ordered pair Q has its coordinate being a negative 11, comma, 2. Now I can just move my point Q to the position a negative 11, positive 2. And that will complete my segment QP, and I know that QM is congruent to MP. In this example, they want us to follow the same procedure as we did in the last example, but here our endpoint is changed. Point P is now 0, 3. We still let this be x sub 2 and y sub 2. Our midpoint is still a negative 3, 7, and those are x coordinates of xm and ym. Then we substitute into our midpoint formula. Here, x sub 1 is still unknown, so that's still going to be x, plus x sub 2 is 0, all over 2. And our x midpoint is a negative 3. Creating proportion and cross multiplying, I get a negative 6 equals x plus 0. Therefore, x is equal to a negative 6. And for my y midpoint, this is going to be 7. Y sub 1 is unknown, so I'll let that be y, plus y sub 2, which I know is 3, all over 2, creating a proportion. I cross multiply and get 14 equals y plus 3, and that gives me y equal to 11. Therefore, the ordered pair for my endpoint Q is going to be a negative 6, 11. Now, all I have to do is move my point Q to that position, and we can complete the segment. Here's a negative 6, and then up 11. Then I know that QM is congruent to MP.